Rolling right away because we've got a full session is Julie Gondzar. She's the Weather Modification Program Manager at the Wyoming Water Development Office. So take it away.
Thank you very much. I'm happy to be here. I tend to get a little bit excited about this topic, so I've got my timer up here to make sure I stay on time, but I'll apologize if I go a little bit over. My name is Julie Gondzar, and I'm a project manager at the Wyoming Water Development Office. And I'm really excited to talk to you today. We have a lot of conversations about water on the ground. And from my perspective, we're going to talk about water in the sky in the form of cloud seeding. Our office is located in the southeast part of Wyoming in Cheyenne. We have about 23 employees and we're a small state agency. So before I advance to the next slide, I just want to briefly explain, and of course I'll go into more detail, what it means to seed a cloud. Specifically, we're talking about wintertime clouds, so cold clouds, and usually we see clouds across the state in certain areas between November and April, so through the winter season. So what it means to seed a cloud is identifying the clouds that already have high potential to produce snow as precipitation and introducing a natural compound that helps to initiate that snowfall process. So with just one slide here for a little bit of history, we're looking at about the 1940s, in which cloud seeding, or the conceptual scientific piece of cloud seeding, was discovered by accident. And it was actually discovered in a General Electric's research laboratory by 3 scientists. And what they were doing is they had a deep freeze chamber in which they were experimenting and trying to learn more about cloud formation. So they had essentially a cloud in a deep freeze chamber. In order to make that chamber colder, they decided to add dry ice. When they added dry ice, they noticed a phenomenon that there were a ton of ice particles that started to collide into snowflakes within that chamber. So that process was sort of the foundation that became what is now cloud seeding. And then down the road, it became understood that a compound called silver iodide also had that same type of effect, to produce ice crystals in a cloud that didn't already have the ability to create them. So again, thinking about the winter storm clouds and cold clouds during the winter time, I'm going to talk a little bit about how this works. So taking a look at the real world and the application of this, you have to have a mountain range, because that is generally our target area. And in the wintertime, you have air moving over that mountain range in which it forms a cloud. And typically, this orographic type cloud formation is pretty static, so the cloud will generally stick around for a few hours. And if you're not a meteorologist, you might find this really interesting, the idea of supercooled liquid water. So we have to have clouds that have supercooled liquid water. Well, what is that? That is when you have water droplets within the cloud that stay in the liquid form but are below freezing. So you can, in fact, have water droplets below freezing that stay liquid. So a lot of times these clouds are really inefficient at producing snow. I apologize, I have to keep looking up at my slides. So in the natural environment, in order for the supercooled liquid water to become snow and fall out of the cloud, that has to attach to a microscopic dust particle called ice nuclei. In the natural environment, that exists, of course, because we have snow and the snow can fall, but we don't have a whole lot of ice nuclei in the wintertime. So generally, this is how snow forms. The supercooled liquid water will attach to that ice nuclei dust particle turn into an ice crystal. The ice crystals will collide and turn into snowflakes and fall out of the cloud. But sometimes you don't have enough of those ice nuclei particles, and that is where you can have wintertime clouds that are very inefficient at producing snow. So that is where cloud seeding comes in. So on the left-hand side here, you can see, number one, you have to have a cloud. Number two, the process of seeding clouds is releasing a natural compound called silver iodide into that cloud. You can do it a couple of different ways. It's aerosolized either from a ground-based generator, where that generator is in one location and doesn't move, so you have to have the right type of weather pattern to make sure it gets over to your target area, or you can use an aircraft, in which that aircraft can aerosolize the seeding agent exactly where it needs to within that cloud. Then you have the dispersion of the silver iodide within the cloud, inside the part of the cloud that has the supercooled liquid water. And of course, you start that initiation process, so you're just giving that cloud a little bit of a boost to create enough ice particles to collide and coalesce into snow, and then the snow will fall out of the cloud. So you have that ability to help that cloud along where it would normally be an inefficient process. So this is kind of what we do when we do cloud seeding, and this is the science behind how that all works. So just a quick overview, the proof of concept is the fact that supercooled liquid clouds can be seeded to produce ice, in which then can deplete the cloud of that ice in the form of snow. There's a lot of reasons to seed clouds. There's a lot of states across the nation that do this, and one of the main reasons that Wyoming does it, or one of the only reasons that Wyoming does it, is for snow augmentation. So increasing snowpack over high elevations of mountain ranges. So think of it as a small scale thing. We have just small scale target areas. And this, of course, is to help increase the supply of water, increase the stream flow. And there's been a lot of conversation in the breakout talks, of course, about habitat for cranes and birds, so helping to increase the water in the region for all of those reasons. There's other reasons for that we can seed clouds. Hail mitigation is a very popular one to reduce the size of hail, to reduce the damage on crops and property, fog suppression, and rain enhancement. It's actually quite common across the western part of the state, and you'll see any area that is colored in blue is where they seed clouds for the purpose of snow augmentation, specifically in the wintertime. Any time where there's a green area, it's typically for rain enhancement or hail mitigation. So there's two different ways to get the silver iodide into the cloud that you want it to be into. And so, like I said before, there's ground-based generators, which are in one location, and they aerosolize that compound into the atmosphere. And then you have an aircraft. So for state of Wyoming, we have two programs. We have a ground-based program, and we have an airborne program. And our airborne program is specifically to benefit the North Platte Basin. So has there been research? Of course. There's been a lot of research done on cloud seeding. The science has actually been cutting edge and come a long way over the past probably 5 or 6 years. This is, I'm not going to go through everything here. This is just a timeline of what the Water Development Office has done as far as research and feasibility studies and operations. So starting on the left here, you'll see in the early 2000s, it was actually one of the conservation districts in our state that put in an application for us to look into a feasibility study for cloud seeding. So the conservation districts had a collective interest in this type of technology. So as the Water Development Office, we said, okay, sure, let's look into it. And we had money appropriated from the state, and we did what turned into a 10-year study. So the Wyoming Weather Modification Pilot Study was a 10-year-long study that looked at ground-based and some aerial seeding and determined if this would be a viable option for Wyoming to use in the future. So the results were positive enough where the state decided to go forth with a ground-based program. And so we started our seeding program in the Wind River Mountains, which is the western part of the state, in 2014. Since then, we've had a bunch of other studies done, and then we started our aerial program in 2018, and we're doing that up to this day. So there's been a lot of studies done, but in the industry of cloud seeding, there have been two major studies, which I like to think of as the golden nuggets of cloud seeding. One of them was our Wyoming pilot study that did a statistical and ensemble analysis looking at seeding several different events. And then the Snowy project, which is a project that was done in Idaho, has been the latest study where they actually documented the first evidence of snow being produced on radar by seeding. So it's been really exciting over the past few years. So after the research was done, we had boots on the ground, and the state of Wyoming decided to go forth and continue with operations. So this is a map of the river basins and where we have our two projects. So the first project that I'm going to talk about is the Wind River Mountains in the western part of the state, with the benefit of the Green River Basin and a benefit of the overall Colorado River Basin. If you're paying attention to any of the news, of course, you know the severity of the drought in the Colorado River Basin. So this project is really a collective partnership between the upper basin states and Wyoming and lower basin states. Our other project is an aerial project for the Medicine Bow and the Sierra Madre Mountains in the southeast part of the state with benefit to the North Platte. So we'll talk about the winds very briefly here first. So target area is the Wind River Mountains. This has been a continuous seasonal project since 2014. We have 10 ground-based generators across this mountain range. And we have an on-site meteorologist that gives us our forecasting, helps us with our decision-making process, and maintains all of our instrumentation. We just implemented a new target area on the west slope of the Sierra Madres. So this winter, we implemented 2 additional ground-based generators to help benefit the overall Colorado River Basin. So here's a map of the Wind River Mountains, and you can see the little icons that look like snowflakes are ground-based generators. We have 9 on the west slope of the mountain range, and you'll notice 1 on the east slope. When we get storms that come in out of the northeast, that generator will generally get turned on. So we can capture storms that come in from the west and the northwest, and the occasional storm in spring and fall that will come out of the northeast. This is just a larger picture to also show our additional 2 generators on the west slopes of the Sierra Madres. So this project is a really great demonstration of a collaborative effort and a partnership that we have with the lower basin states. Because of our legislation and the way that the state of Wyoming appropriates money, this project is required to be a cost share. So 37% of the funds to operate this project comes from the state of Wyoming, where 63% of the funds comes from other water users. And so we have a really wonderful group of lower basin entities that have helped to contribute ever since we started doing our research study. And this is all kind of managed under an agreement that we have that we signed in 2018. Okay, so I'll try to move a little bit quicker here because I can tell I'm going a little slow. So moving on to our aerial program benefiting the North Platte. This is a program we've had going for about since 2018. And we operate a single aircraft. And I should also say that Weather Modification International, they are our consultants for both of our programs. So they operate the generators in the Wind River Mountains, and they manage and operate the aircraft. So the aircraft is based in Cheyenne at our airport, and it basically targets 3 target areas. So we have the Medicine Bow Mountains and the Sierra Madre Mountains. in Wyoming, and then we have an extended target area, the Never Summer Mountains, just south over state lines in Colorado. We have a really wonderful partnership with the Jackson County Water Conservancy District, in which they got a grant from the Colorado Water Conservation Board to help pay for the operations to extend that, to extend over state lines and be able to see their target area also, which just happens to be the upper part of the North Platte. So it benefits for Wyoming as well. Just a couple of pictures here. It's a little bit of a different way to seed on an aircraft. You have flares that are attached to the wing of the aircraft on both sides. These are called burn-in-place flares, and they literally just burn in place, one at a time. It takes about 4 minutes to burn through this entire flare. And here's another picture, kind of looking up, down on an aircraft, and you can see the flares on either side of the wing there. And then there's also ejectable flares, which burn up in about 28 seconds, and they're attached to the belly of the plane, and they are released, and they're about the size of a cigar, and they're released, and they burn up very quickly, also to release the silver iodide into the clouds. So the difference in these two things is that we talked about the supercooled liquid water layer within a cloud. That's the layer that the plane has to fly through. Well, generally pilots are taught not to fly through an icing layer because you'll get icing on your aircraft. These planes are specifically made and designed to hold a small level of icing, but the burn-in-place flares essentially burn through the icing layer, but the ejectable flares are used in a situation where the plane would like to fly above that layer and be able to release the silver iodide in a safer location. This is an example of what a flight path would look like. So off the screen is Cheyenne over here. The plane would fly in, and what you're looking at is the Medicine Bow Mountains right here. These purple lines that are really hard to see are suggested flight tracks based on what the wind direction would be. So in this case, the plane flew a little bit upwind of this mountain range, because again, this very specific area is our target area. So depending on how fast the winds are, you either have to fly further away from the mountain range or a little bit closer. So on this particular day, the winds were quite strong, as they usually are in Wyoming and Nebraska. And so the plane literally flies back and forth for about 5 or 6 hours, or as long as it needs to for the conditions. And then these little icons here are exactly where they either ignited a burn-in-place flare or they dropped an ejectable flare. So that's just an example. We also have some great funding partners for this project. The City of Cheyenne Board of Public Utilities has interest in these mountains with their reservoirs and drinking water for Cheyenne, and I also mentioned earlier about the Jackson County Water Conservancy District. And that is basically my presentation. I will just explain this radar very quickly. Steal a little bit of time, I'm sorry, but the Snowy project that I mentioned earlier documented for the first time ever actual evidence of snow being initiated within a cloud that was not already producing snow with this very high resolution radar. So just for context here, this is the plane flying back and forth along this line here. And you'll see in animation, this is the wind direction. So the winds are coming out of the southwest and the plane is flying back and forth. So let's hope that this animation works here. And what you're gonna notice is a zigzag pattern in the radar reflectivities. You are never gonna see snow bands forming in a zigzag pattern. And if you think about it, with the aircraft releasing the seeding agent in a back and forth pattern and the winds pushing that, that's what's gonna give you that zigzag pattern. You can even see some dots here that indicate that they were ejectable flares right there instead of the burn-in-place flares. A recent development has been really exciting the past 2 years in Wyoming. So this was in Idaho. The past 2 years in Wyoming, we've actually seen a pattern just like this on the National Weather Service radar from our operations. So they're doing a lot of research on that right now, and there's a bunch of papers that are being written. So it's really it's just really exciting to see that. So that's all I have for you today, and I'm assuming questions will take place after because I ran a little bit long. Thank you guys so much.
Thank you very much. Once again, I'm the fill-in moderator for this afternoon's session. So with that, Carla? Yep. Or let me double check. It's good that I know everybody pretty much. So Carla McCullough is the next speaker from UNL. Go ahead.
Thank you, Rachel, and thanks everybody for coming today. I am a watershed science extension educator, and there we go. And I'm basically with a brand new program, new as in almost 2 years on, for me being on board, and it has to do with basically delivering watershed science education for decision makers, or in other words, mostly adults around the state. This one good? Okay. All right, so basically I'm just going to really quickly go through what is our program, what is our strategy, and then I'm going to show one of our example videos that we've produced. So what is Nebraska Waves? We'll talk about engaging adult decision makers, focusing on, primarily in this first phase of our program, natural resources districts, and in particular looking into water quantity and quality issues, both groundwater and surface water, and hot topics that they may be making decisions about. So we'd be remiss to not explain the acronym. We spent a lot of time on this. But it basically stands for Watershed Aquifer Virtual Educational System. And the main point of this, Troy Gilmore's name has been brought up a few times, and he was really the main instigator behind developing this program to begin with. He saw a need and did a needs assessment to see basically our NRDs, where's their baseline level as far as their boards, as far as basic watershed science education. And there was a need determined. And so we're really getting at here is basically that to provide enough basic information that they can make good, sound decisions, and basically, they have a wide variety of backgrounds. So the NRDs, basically, in terms of the initial phase, like I said, are our initial focus for this education. However, we really do hope that it is reaching beyond that and having impact beyond that. As mentioned, they do have a wide variety of backgrounds, experiences, and education. And basically, through evolution of the last 2 years of this program, we've tried various things like modules, or people go through and test, give little quizzes and that stuff like that. They were very unpopular with busy natural resources districts boards. One thing to note is that all 23 of our natural resources districts are unique. They all go through perhaps a different way of orienting the board, introducing special topics and that type of thing. And through feedback with these NRDs, we've basically come up with our way to put the material in front of them is primarily through short videos. We have seen this as basically a way to integrate, they can easily integrate those into their meetings, committee meetings or board meetings, or perhaps board orientations, special retreats or topic meetings. And again, we're focusing on water quality in terms of initially the integrated management planning process, and that's in collaboration with DNR. We're also looking into water quality a lot, focusing on non-point source pollution, and that is primarily in collaboration with our Nebraska Department of Environment and Energy. And then as well, we're looking into the hot topics. What are they working on now? What are they deciding? What water issues are they deciding things about right now? One of them I'll explain a little bit later is nitrate in groundwater. So when we're boiling these things down into these issues down into bite-sized pieces, basically we're really collaborating with a lot of our folks like UNMC, NDEE, DNR, and really trying to take maybe a complicated topic, boil it down to 5 minutes to help lay out that basic framework, and it helps to start conversations is the idea, generate questions and possible solutions for their unique NRDs. We do, by working with these multiple agencies, also we have to ensure that they're feeling okay about these bite-sized nuggets being still accurate, and they're willing to put their names on our credits of our videos. So while this is a virtual system, in acronym, it's really a lot about relationships as well. We are engaging the NRDs at their fall conference, that's the real big one, the legislative conference, and also the spring water conference. However, I've really found one of the most fruitful things that I've done is engage with the NRD staff that are working on information and education or communication. So they're really, we're hoping, are amplifiers as well. Through engaging with actual NRD boards, in particular at the fall conference, we've gotten a lot of great ideas. It's amazing what people will do to sign up for a door prize, so they filled out my little survey. And that is actually how we decide some of the topics of our videos. We have since moved into the social media realm. We have a YouTube channel that we post all of our videos on as we produce them, and now recently we've gotten onto Twitter. So go ahead and follow us if you are on Twitter. We would love that. And then, since we are a baby program and thinking into the future, we have reached out into other areas as well, beyond just NRDs as well, but Husker Harvest Days, webinars with Conservation Nebraska. I gave a presentation for the Vesper Retreat, for example. And what I've come away with a lot of these things, especially Husker Harvest Days, is that there's a real hunger by high school and grade school teachers to basically, sorry, going back. A real hunger for this material for a wide variety of ages. And basically, another part of like moving forward, we're looking into more creative engagement. So I will show this video really quickly. Again, this is about nitrate. It's part of our 3-part series so far about nitrate in Nebraska. The first one's the basics of the issue of nitrate in our water, both surface and ground. And just the second one then is basically about how Nebraska has increasing trends of nitrate in groundwater, and it's an increasingly prevalent challenge. And then the third in our series is the one that I'll show you, is about specifically nitrate in human health. This one I think was most difficult to produce in terms of working with UNMC, because it's really hard when you have years and years of research and many, many papers on the topic to let me boil it down to 5 minutes in a video. But we were able to do it, and we're really proud of it. And at that, I would like to show that.
Welcome to Nebraska Waves. This module addresses nitrate in drinking water and the impacts on health. Did you know that high levels of nitrate in drinking water can cause health problems? In 1992, nitrate started to be regulated in public drinking water systems under the Safe Drinking Water Act. A maximum level of 10 parts per million was set based on studies of methemoglobinemia. This disease is sometimes referred to as blue baby syndrome. While it poses an immediate health risk, chronic exposure to nitrate also poses long-term health risks. Unlike public drinking water systems, private wells are not regulated under the Safe Drinking Water Act. Nearly 100% of rural residents in the U.S. use private wells, and around 21% of those wells exceed the regulatory limit for nitrate of 10 parts per million. For this reason, people who live in agricultural areas and drink from a private well are the primary population at risk. They should test their water regularly and treat it if needed. Other populations at risk include pregnant women and their fetus, infants and children, and individuals with conditions such as anemia, cardiovascular disease, or lung disease. Recent scientific evidence, including studies from the University of Nebraska Medical Center, has emerged linking high concentrations of nitrate in drinking water to adverse health outcomes. The strongest links are associated with methemoglobinemia, colorectal cancer, thyroid disease, and neural tube birth defects. Let's explore each of these a little further. We'll start with the link to methemoglobinemia. High levels of nitrate can interfere with the ability of blood to carry oxygen. This can cause the skin to turn a bluish color and result in serious illness or death. Other symptoms include decreased blood pressure, increased heart rate, headaches, dizziness, fatigue, and nausea. The result in infants is blue baby syndrome. Bottle-fed babies under 6 months old have the highest risk. During pregnancy, it is common for a woman's methemoglobin levels to increase. Therefore, pregnant women are particularly susceptible to methemoglobinemia. Pregnant women exposed to too much nitrate in their drinking water are also at a greater risk of giving birth prematurely. Now let's look at that second link, to colorectal cancer. Researchers are investigating the health impacts of having a combination of agrochemicals in drinking water, such as nitrate and atrazine. Generally, when you put nitrate and something like atrazine or other pesticides, red meat, or certain drugs in an acidic environment like our stomachs, they react and create N-nitrosyl compounds, or NOCs. Extensive animal research has shown that NOCs cause cancer in animals. There are also numerous studies linking drinking water nitrate exposure to negative health impacts in humans. Most colorectal cancer studies have found evidence of an increased risk of colorectal cancer associated with nitrate in drinking water. Since information from private wells is limited, most of these studies used data from public water systems and therefore had nitrate contamination below the regulatory limit. Research is ongoing to characterize the risk of colorectal cancer for people using private wells. Let's move to the third link, thyroid disease. Most studies have found evidence for thyroid disease being associated with higher levels of nitrate in drinking water. This effect is seen most among children and pregnant women where nitrate levels were close to or above the regulatory limit. Finally, we'll look at the fourth link, neural tube birth defects, which affect the spine, brain, and spinal cord. Maternal exposure to the combination of nitrate and other agrochemicals like atrazine may increase risk for birth defects in humans. 1 in every 33 infants in the United States is born with a birth defect. In Nebraska, 2 of every 33 infants born has a birth defect. That's double the national average. While research is ongoing, one meta-analysis showed that 5 of 6 studies linked nitrate exposure with an increased risk of neural tube defects when exposed to drinking water nitrate below 10 parts per million. Beyond these 4 major links, researchers have found other potential links. Some studies suggest an increased risk of pediatric cancer, bladder, ovarian, and kidney cancers, non-Hodgkin's lymphoma, Alzheimer's disease, and Parkinson's disease. Research continues to find answers for these potential links. Water plays a major role in human health, agricultural production, and community prosperity. By implementing practices which ensure the safety of their water through testing and treatment, all Nebraskans can participate in ensuring a healthy future for the state.
That was all I had for a presentation. I will just say one of the creative ideas we had is to take these videos out to small town, rural Nebraska, where maybe they have a movie theater, where maybe they also have source water protection issues, and do a movie night. So I'm just starting to think outside of the box in terms of not just throwing these up on YouTube or on our website and expect to have impact. So that's it for now. Thank you.
You're going to be around for, I'm sure there's lots of questions relative to that, and we will probably try at the end for questions. Okay. Our next speaker is Professor Vijendra Boken from UNK.
Thank you. It is just Vijendra, not Vijendra or Vijendra, just as it reads. Vijendra Boken. Yeah. Okay, well, good afternoon. My name is Vijendra Boken, and I just added another name into this talk, Dr. Huck. He's a professor at the University of Manitoba in Canada, and this research is it's not a very preliminary stage. I think when I saw the invitation to talk at this conference, I started thinking actually what to talk, and I have done some work on agriculture drought, and so since this was on Platte River, so I thought maybe I could collect some data and analyze it and study the hydrological drought actually in Nebraska. So the topic, as you see, that it is on impact of dams and reservoirs. There are many in Colorado and Wyoming and some in Nebraska. And so I wanted to see how the frequency of hydrological drought is affected by this. And as I said, that it is an initial stage, so it needs a lot more data in order to draw concrete conclusions. But this is, I need to engage both my hands, I guess. I don't know. I'm a left-hander. Mm-hmm. Okay, so these are the contents of my talk, hydrological drought and their impacts, as you know that how they will be impacting the hydrological flows. Not at many places, I just analyzed one site on the Platte River, and I chose the site, I will tell why, and I'll give you some information about the number of dams or reservoirs in Nebraska or North Platte or South Platte, and then something about river discharge analysis. I collected discharge data actually from 1931 to 2021. I missed 2022 because it is not yet complete, but it would be worth analyzing that. And yesterday I listened to talk to some Mr. Paulman, and he was talking that they did not even harvest dryland crops this year. Actually, it was agricultural drought, so it would be good to see. So there are many things that we can work on this, and as I said, that I just did this in a little shorter time, and would like to continue. And if you have some money to support undergrad research, and you don't know what to do with your money, so UNK will happily take it and engage in some research. So we'll talk about defining agriculture drought and determining the frequencies, and I will have some concluding remark on this. So when we say drought, there are a lot of definitions, more than 100 definitions of drought, but mainly this meteorological drought that depends only on precipitation, and agricultural drought that depends on the crop yields, and the hydrological drought when we look at the water levels in rivers or reservoirs or these things. So, and we can define the hydrological drought that is most appropriate actually for Nebraska or for stakeholders downstream. That itself is a research topic, I think. So, as I said that I'll focus on these on a very short span of the length of the Platte River actually flowing in Nebraska. Okay, so this is the definition of percentages I just put myself actually, but there's a need to define or narrow down these definitions of mild hydrological drought or moderate hydrological drought or agriculture drought. And I just selected 0 to 20%. We collected the data of discharge data, daily discharge data for from 1931 to 2021 or 22. And every year, based on the daily discharge, I calculated the average daily discharge based on the data 65 or 66 values, and got the average, and then compared the annual average from this, yearly average from the multi-year average, and if the value was 20% below or 0 to 20%, that we could say mild hydrological drought. If it was below in the range of 20 to 40%, it was moderate hydrological drought, and if it was higher than 40% below the average, then we could say severe hydrological drought. But again, as I said, that drought is a perception. It is not simply these percentages may work in some cases. We can come up with the appropriate definitions in case of Nebraska, but they may not work in other cases. Actually, it is very subjective, and it is a matter of perception. Actually, what exactly, how severely you get affected. So, what for are you using this data? And so there's I think research that is need to be done. I think in any region or depending on the needs of the stakeholders. Now, this is the Platte River Basin. It has the North Platte and South Platte and Central Platte, and as you all know. So this is some information about the dams on the Platte River. Particularly pay attention to the year when these dams became operational. So there's a Pathfinder Dam, 1909, or Guernsey Dam, 1928, then 1938, 39, 51, 44, 61. This construction of dam was much frequent actually early on, but I think after 1980, there's not many dams, and there's some hue and cry from the environmentalists, and so we are not seeing so much of dam construction as we saw, particularly after 1930s, and there was a great need to water storage or irrigation, and these are the purpose of these dams. Actually, some of these dams were built for hydroelectric power generation, from some for irrigation, and some for water storage or supplying, providing water supplies to the cities actually. So particularly, these are some location of these dams in the North Platte, and similarly from South Platte. They are big dams that supply water to Denver city or greater Denver area. And there are some dams that were built to regulate water in another dam. And so some lakes, as you can see, some dams were built to prevent floods actually. In 1965 there was a big flood, so these are the purpose of these dams actually. And they continued into 1983. And these are some of the dams mainly for hydroelectric power generation in Nebraska. And some of these dam locations, they were connected with each other. They were drawing water from the Platte River, and then in hydroelectric power, at least the water might be going back to the river, so it might not have much impact on the flow, but it needs to be seen and studied. I just did not have time to look into all those details, but if we talk about irrigation or water supply as the time goes by, I think the need for water supply or for irrigation, need for making, bringing a lot more area under irrigation to increase food production, that will continue. So water demand for irrigation or water supply, depending on the population increase, that will continue. But the amount of water that will flow in the river, that will not change much actually. So we might see the severity of drought or hydrological drought actually much more in the future. These are some of these location of these dams actually in Nebraska. So the objective again was to study the impact of these on the frequency of hydrological drought, and ideally it would be good to have the stream flows for sufficiently long period of time even before the dams were constructed. But that was not the case. The data I collected in Nebraska began in 1931, and some dams were constructed actually prior to that, so we are missing some data, and I don't know, we might in future collect data from Wyoming or Colorado depending on the time and resources that we have. And so I collected the data from USGS site and this waterdata.usgs.gov, and there are several sites actually. I was looking for the site that was just close to the dams I had considered prior to Kearney. I live in Kearney, so I wanted to see the impact of flows in Platte River, particularly keeping in mind the flood that occurred in 2019. So close to Kearney, I could see that the Overton was the site that I collected actually, and for which the length of the data was sufficiently large from 1931 to 2000. No other sites nearby had that long data sets, and all the dams were west of this site. So I could expect that maybe it will have the nearest site soon after these dams was Overton actually. That's why I analyzed the data on Overton. So the methods, now the question was, this entire length was divided into 3 segments. One I was, because some of these dams that were constructed in Nebraska were in 30s actually, in 36 or 38 or 41 and the very short length I had prior to construction of these dams, so 1931 to 34. There was a first segment which was very short, and then another post-dam range 1935 to 75. In that range, I think majority of these dams were constructed in that. The last one was towards the end of the, close to 1980. And then the last segment of this data was from 76 to 2021. So 41 years of data or 46 years of data. And in the later years, I see that all the dam, anything that is happening prior to that will have impact on the frequency of hydrological drought. So the next few slides will show you how the daily average that was calculated by the annual values, all the values in a year. So from 1931 to 34, the trend was that the river flows were declining, and now this may not necessarily be due to dam construction. There will be certainly some impact, but there may be natural factors and then man-made factors. Man-made means construction of dam. If you are storing water, if you're diverting water from the river, that will have some impact. So it shows some, and 1930s were all naturally, I think, very dry period. So maybe we need to look at the rainfall data. Some years the river did not have any data. There were 0 values. I don't know if it was really true or something. I didn't really have any sources to verify that, but I saw some years river were completely dry in 1930s. Yeah. So there's a declining trend, but 1935 to 1975, you see this for long period of time, the river level were just, the average was like 1361 cubic feet per second, and it was kind of a constant, little variations from that value, and later on it started rising for some time, but again underwent very dry periods. And this is, you can see that initially in 1984-85, it was a high level, but later on it decreased. But again, this average is a little bit higher than the average from 1935 to 75. But at the same time, your needs for water from the river has increased. With the time, everybody needs more water, we need, and the natural flows will maintain the same level, go up or down for some time, but the water availability will remain basically same, but the demand is increasing. So the hydrological drought that we perceive today is much different than the hydrological drought 50 years ago, because it depends on the needs, and our needs have increased. So even if the average value has increased, the severity may not. So this is the result of the analysis that I did from the discharge levels at Overton site on the Platte River. And so as you can see, the first segment, 1931 to 34, was a very short period, nothing concrete to conclude from that range. It was very short range. But you can see the mild severe drought occurred almost 25% of time, means 1 year out of the 4. In the next segment, 1935 to 75, you can see the total length was 41 years, but 12 times mild drought happened, and 8 times moderate drought, and 7 times severe hydrological drought occurred in that range. So percentage-wise, 29 to 19, and then 17% severe drought occurred actually prior to 1975. And in the last segment, which was from 76 to 2021, you can see that the number of mild or moderate drought, 10% time, 15% time, mild drought decreased. The frequency of mild drought decreased actually, but the severity of severe drought, frequency of severe drought increased. You can see from 17% to 37%. So this is a little bit concerned that as we are, going into the future, the frequency of severe drought tend to increase. And again, this may be the impact of more water being drawn from the river upstream side, or in addition to some climate change impact. And as the climate forecasters say that due to climate change, I think the dry area will get drier and the wet area will get wetter. So this is some concluding remarks from the climate experts actually. So there's a very combined effect, but certainly what we perceive that the frequency of severe drought will keep on increasing in future. So again, as construction of dams, certainly they will continue to impact the water flows in the river. And in the present study, I said sufficient data for pre-dam period was not available. It was only 4 years that I had data prior to the dam construction in Nebraska, but we'll look more into some of the sites, maybe in Wyoming and Colorado, and see that on more number of sites we see the impact of drought. If you want to discern the impact of drought, dams or reservoirs, we will have to go into deeper analysis. So as I said, that 1931-21 data was analyzed, and in the later half, in the recent years, in the recent 30-40 years, the frequency of severe drought has increased actually significantly. Again, this is another topic to really see how much the increase in frequency is due to the dam construction and how much it could be due to other factors, including climate change. Again, this is just a preliminary analysis, and as I said, if we have some some funding or some time and resources, we will continue this. And so that's all I want to say. Thank you so much.
Thank you so much. You can ask questions in the app, and folks, I guess I'm reading the little cheat sheet here. Speakers, you can answer them within the app as well. So next we have 2 presentations that were submitted virtually, I guess. Great, folks. So the AV guys are nodding yes. So Ellen Wohl, a professor of geology from Colorado State University, has a presentation on dimensions of river connectivity. And Dave Aiken, professor and ag and water loss specialist from UNL, has a presentation on South Platte River issues. And so those will be available for viewing next. And of course, they are also available, as I understand it, to answer questions via the app as we are watching their presentations. So everything will now enter a hybrid mode for the next portion of the session. So with that, I will put this down.
Hi, I would like to talk about dimensions of river connectivity, and specifically in the context of the Platte River Management Program. So I want to just give a little bit of background on the phrase I'm going to use throughout the talk, a river corridor. And I use that phrase rather than just saying river, because most of us, if we hear river, just think of the active channel, whereas the river corridor includes the channel, the adjacent floodplain, and the underlying hyporheic zone. And if you're not familiar with that phrase, hyporheic zone, it refers to subsurface water where the water originates in the active channel, goes into the subsurface for some distance, and then returns to the active channel. So it's a little different than groundwater, which can originate outside of the river corridor. One of the key aspects of the river corridor is that it has strongly 3-dimensional connectivity. So there's lateral connectivity between the channel and floodplain, longitudinal connectivity up and downstream within the river corridor, and vertical connectivity between the surface and the hyporheic zone and the underlying groundwater. This is a kind of a busy block diagram, but the different arrows in here that were designed specifically to refer to water and solids, I think, can make the point that materials don't just simply move downstream in channels. They move downstream in fits and stops. Particularly sediment can have long periods of storage on the floodplain, and there is this strongly 3-dimensional component in natural, fully functional channels. There's also 3-dimensional connectivity beyond the river corridor with the greater environment. There are, of course, water and sediment come into the river corridor from the atmosphere through precipitation and dust deposition. Volatile chemicals can enter the atmosphere from the river, and aquatic insects can move in both directions. There are one-way inputs from the adjacent uplands, water, whatever is dissolved in it, mineral sediment, organic matter. There are two-way vertical exchanges between the subsurface, the deeper subsurface like the groundwater, mostly water and solids, but also some forms of aquatic insects. And of course there are upstream and downstream connectivity. All inanimate objects move downstream, but there are a variety of organisms that move upstream, such as the paddlefish shown in this inset photo. Okay, so why does this even matter? Well, the degree to which the river corridor has 3-dimensional connectivity within the corridor or is connected to the greater environment makes a difference for water supply. If you have a lot of exchange between the active channel and the floodplain, for example, you can have extensive floodplain wetlands with surface water storage. If you have vertical connectivity, you can have subsurface water storage in the hyporheic or groundwater. That makes a difference for water quality, aspects like suspended sediment and turbidity. But nitrates move in solution, and microbial communities in the floodplain and in the hyporheic zone are very effective at removing nitrates. Phosphate tends to travel adsorbed or physically attached to fine sediment, so it goes where the sediment goes. Dissolved oxygen, dissolved organic carbon, water temperature can all be strongly influenced by hyporheic and groundwater exchange. Habitat abundance and diversity are certainly strongly influenced by the degree to which connectivity is present or not. And I say it that way because some very natural functional river corridors have limited connectivity in one dimension or another. In a smaller river, you might have a whole series of beaver dams, for example, that limit longitudinal connectivity but promote lateral and vertical connectivity. So it's not just that connectivity is necessarily goes in one direction as a river is more and more functional. It's that there are natural levels of connectivity and they strongly influence habitat abundance and diversity. Biomass and biodiversity are influenced by habitat and by other things, but those other things being equal, then if you have more habitat abundance and diversity, you typically have more biomass and biodiversity. And all of these can influence what's sometimes referred to as ecological integrity, and it's the degree to which the ecosystem is in a natural state and is fully functional, and physical integrity, which is simply the ability of the river corridor to adjust to changing inputs, primarily of water and sediment. If you imagine an urban channel that is completely stabilized in concrete, for example, it has no physical integrity. If you put more water in, the water just goes faster. There's no adjustment in channel size. Connectivity can also strongly influence the resilience of the river to relatively short-term disturbances like wildfire, flood, or drought, or to sustained disturbances like climate change or human consumptive use of water. If I go back to the example I used before, where you have a lot of floodplain wetlands or a lot of vertical connectivity that creates a high riparian water table, for example, that's going to make that river corridor more resilient to fire and drought. And if you have a high degree of connectivity between the channel and the floodplain, you may have more natural riparian vegetation that creates a lot of hydraulic roughness and slows down the passage of floodwaters. So that can increase resilience to floods, as an example. So fundamentally, what creates and maintains connectivity? Well, really, water and sediment moving into and through a river corridor vary naturally through space and time. There are floods, there are droughts, there are pulses of sediment associated with, for example, debris flows in mountainous areas or with tributary inputs in lower gradient systems. And those fluxes create adjustments in the river corridor form, what I referred to before as physical integrity, and in the biotic communities, ecological integrity. So to think about this, or to illustrate it a little bit more conceptually, when I think of how a river corridor works, I think of fluxes. In all rivers, that includes water and sediment, and in forested rivers, it can also include large wood. Certainly that was very important historically. Again, those fluxes vary through time and space, but they interact with what I've called the physical context here, primarily valley geometry. So are you in the headwaters? Are you lower in the basin? What are the spatial limits in the river corridor? These two photos, the one on the right here is a very broad floodplain that's tributary to the Yukon River in interior Alaska. Contrasting that on the left, that's the Colorado River in Grand Canyon, where it's very narrowly confined by bedrock valley walls and a very coarse substrate. So there are fundamental spatial limits on how far a channel can move or how large a floodplain can be. Boundary erosional resistance is part of that. In the example on the left, those bedrock walls are not easily erodible, for example. And base level stability, what's going on downstream? Is the downstream channel cutting down, or is it accumulating sediment, or is it stable? So this context is really set by the parameters that I've just gone through. And you might be thinking, well, how do humans come into this? We don't usually change valley geometry, but what we do is change how the channel and floodplain interact with that valley geometry. So we regulate flow, for example, through dams and diversions, or we build artificial levees or stabilize the banks or channelize the active channel. But all of those influence those interactions between the fluxes and the context. So the fluxes moving through that physical context result in a whole series of characteristics, including connectivity. And again, these are occurring in a river corridor. So what do we do that influences this? Well, primarily we alter water and sediment fluxes. Water, the big one, is flow regulation. Sediment, we can decrease sediment fluxes by storing sediment in reservoirs. We may have aggregate mining in the channel or floodplain. We may stabilize the banks or channelize the river. But we change both the sediment supply or sediment availability and the ability of water moving through the river corridor to transport sediment. We also directly and indirectly alter the form, the physical form of the river corridor and the biotic communities living there. So direct, again, things like artificial levees, channelization in the northern hemisphere, removing beaver and the dams that they build, either taking out riparian vegetation and removing in-stream large wood, or inadvertently or deliberately introducing exotic vegetation or creating conditions that allow native vegetation to expand dramatically. And indirectly, we alter what comes into the river corridor, so water and sediment fluxes from the uplands, mainly by changing land cover or, in some cases, changing topography of the uplands. Think about construction of urban areas or construction of road or railroad corridors, for example. And just as an example of this, we had fun with this title. This was Rich Knox's PhD work that he finished last spring, and he looked at the extent of artificial levees in the contiguous United States and then thought about the implications for floodplain function. So you can, basically, these are things that I've just talked about, the fluxes of material, the habitat abundance and diversity, biomass, biodiversity, hazard mitigation. All of these are altered and in many cases dramatically reduced by the construction of artificial levees. So it's really impacting floodplain functions, as an example of what I was talking about in the last slide with some of these human alterations. So turning to the Platte, what's missing on the Platte? I would guess that many of you are familiar with this book that I've gotten the inset here from the National Academies Press a few years ago. As you are undoubtedly very aware, there's been an expansion of woodlands and a narrowing of river channels, and that's led to the loss of these relatively unvegetated sandy areas that are near shallow water that a lot of migratory birds like for feeding and nesting. It's also led to the reduction of braided channels that are quite unstable and tend to move back and forth from side to side, so shifting sandbars on islands, the sandy substrate that goes with that, and fairly warm, turbid waters with a very strong annual snowmelt peak. Those changes, in combination with the physical barrier associated with dams that restrict longitudinal migrations, have influenced fish, some of the threatened and endangered fish species. So fundamentally, these changes reflect a loss of longitudinal connectivity, mainly for water and to a lesser extent for fish. And that loss of longitudinal connectivity for flow is really expressed as what I've called compression of variations in flow magnitude. If you imagine a hydrograph, so you might have flood peaks up here and the base flow down here, flow regulation has basically done this. We've reduced the flood peaks that historically would have removed some of the newly germinated riparian vegetation, and we've increased the base flows, so we've really just made it a lot easier for the vegetation to establish and grow to maturity, and that's exactly what the vegetation has done. So we see these changes over the past century. So I think going forward, the real challenge for river corridor management on the Platte is both to restore, and I said or, but it could be either or, restore the river connectivity to the extent possible in terms primarily of flow and sediment and in some cases for fish, or mimic the effects of restored connectivity by deliberately creating some of the forms and processes that would be maintained if we had natural levels of connectivity. And of course, in the Platte, that often means removing vegetation that has encroached on the active channel and reconfiguring the channel and floodplain to create a more shallow, rapidly shifting environment in the channel and greater hydrologic and sediment connectivity between the channel and floodplain. And these are tremendous challenges. I fully acknowledge that. Thank you.
Hello, I'm Dave Aiken, and I'm here to talk about South Platte River issues between Nebraska and Colorado. Okay, this is a map of the Platte River, North Platte coming out of Wyoming, South Platte coming out to Colorado. You see this little black mark here. That is the division between the upper South Platte River Basin and the lower South Platte River Basin. And that's pretty important in terms of, what the legal situation is regarding conflicts between Nebraska and Colorado. Okay, some basic things about the South Platte River. Of course, we're concerned about potential water developments by Denver that could reduce flows into Nebraska. So the question is, how much legal protection do we have under the South Platte River Compact? Okay. Now, I showed you the dividing line between the upper section and the lower section, the upper 3/4 or the upper 80% or the bottom 20%. The upper part, the upper 75 or 80% basically belongs to Colorado to do with what they want. I call that the Denver section. And the lower section is where our water rights are. And, we only have water rights in the lower section. We don't have water rights in the upper section. Now, that's just my opinion. Of course, if this ever ended up in court, Nebraska attorneys representing Nebraska might make a different argument, but to me, the plain reading of the compact says that, Nebraska is just involved in the lower section, not the upper section. Basically, the purpose of the compact was to make sure that Colorado would administer surface water diversions by Colorado irrigators in the lower section to protect the western canal that served irrigators in Nebraska and Colorado. So that when, the Nebraska basically made a call that the Colorado state engineer would shut off the junior appropriators on the South Platte, enough of them so that the Western Canal would get its 120 cubic feet per second, or CFS. In addition, in the lower section of the South Platte, Nebraska is entitled up to 500 cubic feet per second off-season flows. These are basically the winter flows to supply the as yet undeveloped Perkins County Canal. But there's a limitation. Colorado would have the first claim on up to 35,000 acre feet if they developed, storage projects within that lower section of the river. Okay, since 2002 and through today, Colorado and the southwestern United States are experiencing a mega drought, and it's been pretty bad in Colorado and the Southwest. They've been hit pretty hard with drought. And, we've got some drought in Nebraska this year, but they've been having it for 20 years. So they're in pretty bad shape. In 2002, they shut down over 4,000 junior irrigation wells in the South Platte River Basin. They did this because their makeup water in the reservoirs, some of them up in the mountains, had dried up. And if the junior wells weren't able to call the water out of those reservoirs to meet senior surface appropriators, then the wells get shut off. And they were shut off, and they've been shut off ever since. Well, the whole state of Colorado has been trying to figure out, how do we deal with this drought? If the scientists are right, and this could be what the future of water looks like in Colorado, as well as the entire Southwest all the way out to California, if this is what it looks like, what can we do? What can we do to try to hang on to the irrigated agriculture that we have and to have enough water for our cities and so forth? So there's a whole bunch of things they've been doing, and they've been doing it on a statewide basis, not simply basin by basin, but we're interested in the South Platte, of course. That's what affects us. And there have been quite a few things that have gone on there. I'll just note real quickly, the 2020 South Platte Regional Opportunities Water Group, or SPROG, they did a feasibility study of a project that has got the people in the South Platte Basin in Nebraska all up in arms. And so we'll see about that in just a second. But that 2020 SPROG report was based on a state study that was done or published in 2017. This was authorized by the Colorado legislature, and the purpose was how much unappropriated water is there in the South Platte River Basin on an annual basis above and beyond what we need to give to Nebraska under the South Platte Compact. So, if we could do everything we could to make sure that Nebraska only got the water that it was entitled to under the South Platte Compact and no more, how much water would we have for in-state development in Colorado? That was the purpose of the study. Long story short, somewhere more than 300,000 acre feet potentially available. Wide variety, if you see in the first bullet, ranging from 79,000 acre feet to 951,000 acre feet. That's a pretty wide spread. So some years it's not much, and some years it's an awful lot. But anyway, that's the amount that they're looking at, and so they're saying, okay, if we've got 300,000 in some state, in some years, maybe 400, 500, 600,000 acre feet of water available in Colorado, in the South Platte Basin, what could we do with it? Well, and before we move on to that, if the Perkins County Canal were operational and got the full winter flows of 500 CFS that it was entitled to under the compact, what would that do to this 300,000 acre feet plus? Well, it'd knock a big hole in it. It's over about 130,000 acre feet. So that would take a fair chunk, over a third, I guess, of the water in the potentially available for in-state use in Colorado. Okay, this is the map of the SPROG project. And you see, the river here, Denver up here, and the South Platte flows down, and you see these orange circles, 4 of them. Those are potential storage reservoirs. And so you follow the river down, the South Platte down to where it gets close to the crossover line between the upper basin and the lower basin. And basically what they propose to do is to divert water, not too many miles upstream from the dividing line between the Denver 3/4 and the Nebraska 1/4. I'll call it that. And in theory, what they want to do is to dry the South Platte River before it hits the lower reach. And if they can do that and be legal under the South Platte Compact, which I think there's a pretty good shot that they could do that under the South Platte Compact. If you notice the reservoir near Julesburg, that's a smaller one, but that's, if they've got water in the lower reach that isn't under a call from the 120 CFS that Nebraska is entitled to for the Western Canal, then then they'll take that water out, divert that water from the river as well, put it in the storage reservoir, and eventually pipe it back to Colorado. Pipe it back to Denver. Okay, I think everybody has heard about the $500 million proposal that Governor Ricketts made last year. The legislature appropriated a little more than 10% of that to begin initial planning and other activities associated with looking at developing the Perkins County Canal. And a lot of people have fixated on the $500 million and saying, is it really worth it and all that. I think that's not the best way to look at it. I think a better way to look at it is we're in a chess game with Colorado over the 500 CFS for the Perkins County Canal. And Colorado wants as much of that 500 CFS as they can get to keep, for potential in-state uses in Colorado. We'd like to see whatever's coming over now, and ideally we'd like all of that to continue coming over. If it's can't get it all, maybe we can negotiate something with Colorado on sharing those winter flows, off-season flows. But I think it's fair to say that Governor Work has got Colorado's attention. I have no idea where the states are in terms of any conversations. We have to keep in mind that the Sprague proposal is just that. It's a proposal. It's not a project. It has a long ways to go before it constitutes a real threat in the sense that, they're starting to acquire land and pour concrete and all that stuff. They're years away from that. But, we can't just pretend it's not happening, and so it's we're kind of where we are right now. One thing that has not come up, at least in the research that I've done, that has not come up in this conversation about the South Platte River is the Platte River Cooperative Agreement for the endangered species. And as we know, the Kearney, Grand Island, east of Grand Island, that Big Bend reach of the Platte River is whooping crane and in other endangered species habitat. And in 1997, under the Platte River Cooperative Agreement, Nebraska, Colorado, and Wyoming all agreed to do what they needed to do to protect the flows through the habitat from any new water uses or diversions that occurred in their state. So if the Sprague project goes anywhere before they can do dirt work and stuff like that, they'll have to go through environmental review and get federal environmental approval under the National Environmental Policy Act. And part of that, an important part of that, will be what will this do to the habitat flows into the Big Bend Reach in Nebraska. And if the studies come back saying, well, that's going to hurt the flows in Nebraska, then Colorado is going to have to come up with a plan to increase those flows to offset the reduced flows, from the Sprague project if it goes ahead. On the other hand, if the studies come back and say, well, it's really going to be hard to tell whether there's going to be any reduced flows or not, because that central Big Bend Reach is so far away from what's going on in Colorado that a lot of that water that might have come to Nebraska otherwise, not a lot of that would have gotten to the Big Bend Reach. And so it's hard to tell whether there's any harm from this Sprague project or not. And if that's the case, then Nebraska is just back on arguing the compact or something like that. But so there's a lot of uncertainty. There's a long ways to go, but it's certainly an issue that we have to watch, and because it's something that could affect Nebraska pretty substantially. Thank you.